a is greater than or equal to 1, we have to find all the complex numbers z which satisfy the equation z plus a into modulus of z plus 1 plus iota equal to 0, right? So for this given equation, let's suppose that z is x plus iota y. And from equation 1 we get, just put the value of z equal to x plus iota y in 1, we get x plus iota y plus a into modulus of x plus iota y plus 1 plus iota equal to 0. Then it is x plus iota y plus a. Alright, modulus of any complex number is, yes, square of the real part plus square of the imaginary part under the root plus iota equal to 0. Collecting the real part, we get x plus a into square root of x plus 1 whole square plus y square plus iota into y plus 1 equal to 0. I can write this 0 as 0 plus 0 iota, doesn't matter. Equating the real parts and imaginary parts, we get x plus a into square root of x plus 1 whole square plus y square equal to 0 and y plus 1 is equal to 0. From here we get y equal to negative 1. And just putting y equal to negative 1 in x now, we get x plus a into the square root of x plus 1 whole square plus y square, that is negative 1 square, which is 1, equal to 0. Now the condition is given to us that a is greater than or equal to 1, right? So here a is greater than or equal to 1 and the square root part should always be positive. So for this equation to be equal to 0, this x must be less than 0. Yes? Alright. So as a greater than or equal to 1 and square root of x plus 1 whole square plus 1 is positive, we must have x less than 0. Taking this x to the other side, we get a into square root of x plus 1 whole square plus 1 equal to negative x. And now squaring both the sides, we get a square into x plus 1 whole square plus 1 equal to x square. And then on simplifying this, we get the quadratic equation in x as a square minus 1 into x square plus 2a square x plus 2a square equal to 0. Now a is given to be as greater than or equal to 1. What if a is equal to 1? And what if a is greater than 1? So for this equation, if I take a to be equal to 1, what I get, putting a equal to 1 over here, we get 0 in the first term and then it becomes 2x plus 2 equal to 0. That is, we get x equal to negative 1. Right? And just we have written that we must have x should be great. And just now we have written that we must have x should be less than 0. Right? So x is negative. Fine? Alright. So case 1. If a equal to 1, we are getting x to be as negative 1. Suppose a is greater than 1. If a is greater than 1, then we are getting, from this equation, we are getting the roots of x as, yes, x equal to, yes, it is negative b, that is minus 2a square plus minus square root of b square, that is 4a to the power 4, 4 times a square minus 1 into 2a square. Divided by 2a. divided by twice of a square minus 1. So further, this is equal to negative 2a square plus minus, alright. If you solve this, you get 4a the power 4 minus, it is 8a the power 4 plus, again it is 8a square, right? So this becomes negative 4a the power 4 plus 8a square. Taking 4a square common, we get 2 minus a square, right? So this becomes 2a into square root of 2 minus a square, right? So it is 2a square root of 2 minus a square divided by twice of a square minus 1. Just cancelling 2 from here, we get negative a square plus minus a into square root of 2 minus a square divided by a square minus 1. So this is the value of x for a greater than 1, right? Okay. Now in the bracket, I'm having 2 minus a square, and the term under the square root cannot be negative, right? So if I take the value of a to be as square root 2, then I'm getting 0 inside the square root, right? I should not get negative number inside the square root. For that, a should not be greater than square root 2. Because if a is greater than 2, then you are getting negative number inside the square root. And for that, you will get x to be as your imaginary number. But x is the real part of z, right? So, for a greater than 2, there is no solution. So, if a is greater than square root 2, then the given equation has no solution, which means we are getting the solutions for a greater than 1 and a less than equal to square root 2, right? So the valid condition is for a greater than 1 and less than equal to square root 2, we have the value of x as negative a square plus minus a square root of 2 minus a square divided by a square minus 1, right? And for this condition, I'm having y equal to negative 1. So the required complex number is x plus iota y, that is, this is your x minus a square plus minus a square root 2 minus a square divided by a square minus 1. This is your x plus iota y. Y is negative 1, or you can also write this as negative iota, right? So this is your required complex number. Thank you.